All right, we're back. We're on page 2 of notes 9 of Calc C. We're talking about power series. We talked last time. A Taylor series is a type of power series. Not all power series are Taylor series. It's really just an infinitely long polynomial where there's some kind of discernible pattern in the coefficients. I guess maybe there doesn't need to be a discernible pattern as long as someone asserts that there is, but I don't really know. That seems a little beyond the scope. Let's talk about how we're going to find the interval of convergence, because that's where it's at. That's like the big deal with these. And so to find the interval of convergence, there's a reason I'm excited about it, and you can see it right here. We get to use the ratio test. So what you're going to do is you're going to find the open interval on which the series definitely converges, not just definitely converges absolutely. So that's a better kind of convergence. So it will converge absolutely on the interval. Then that interval is going to have endpoints. What we'll do is we'll take the endpoints and we'll plug them in. When we plug them in, we get a series of constants, right? We don't have a polynomial anymore. We just have a series of constants. We're going to see what happens with each of those, and then we'll state the interval. So let's see if we can do it. So here, I am a fan of breaking this up first. You don't have to do it. I mean, you know, people do these in different ways, obviously. So I'm going to find the limit as n approaches infinity of. So remember, we're using the ratio test here. We're finding the open interval on which it converges absolutely. So 2n plus 1 x n plus 1 over n plus 1 factorial times reciprocal n factorial 2 to the n x to the n. So I like to break it up so I can see each base to an exponent. All right, so if we clean this up, we're going to have some things that kind of like go together, right? So this will go with this, leave it with just 2. This and this. So now there's going to be an x, and x is a wild card. So we can't just drop the absolute value around it. It needs to stay inside the absolute value. And we'll deal with that when we get to it. And then these are going to cancel with each other. So this is going to give me this and this, leaving me with just 2. And then do I still need a limit? Oh, I still need a limit because there's still going to be n's. All right, start with a limit. Limit as n approaches infinity. So we had 2. And then this and this leave me with an x. X could be positive, could be negative, because n is the thing that's changing. So we need the absolute value of x over n factorial. So we have n plus 1 times n factorial. So just n plus 1. Now we're taking the limit as n approaches infinity. So if n approaches infinity, x is a constant. So it could be a huge constant, but it's just a constant. So x is a constant. So a constant divided by n plus 1. This is 0, which is less than 1 for all x. So it doesn't matter what x is. This thing's going to converge. And so because that happened, we can say the series 2x to the n over n factorial converges for all x. We could say for x as an element of the reals. Either of those I think is good. The radius of convergence. So if it converges for all x, the rate, or I guess we could write, how do you even write that? I don't want to write that. Okay, so the radius of convergence is infinity, which is a weird one to start with. Because you start at 0 and you go infinity in either direction, and it's you still get convergence. You may have noticed that this series is really just e to the 2x, right? So e to the x is x to the n over n factorial. This is just e to the 2x. So we already actually knew it was going to converge, maybe, potentially. Like I was pretty sure. All right, let's try another one. So we need to first do, there's nothing to actually peel apart here because this is a factorial. So like it's not 2 factorial, n factorial, it's just 2n factorial. So here we'll do the limit as n approaches infinity, absolute value. All right, so it's going to be 2n plus 2 factorial, x to the n plus 1, n plus 1 factorial times at n factorial, you got 2n factorial, and you have x to the n. Okay, so this is the limit because there's going to still be x's. All right, So now n is going to infinity, so we don't really need absolute value around n type things. Should I highlight like this and this play together? I mean, I'm pretty sure you can pick these up, but it's like once you start down a road, it's hard to get off the road. All right, so I'm gonna say this is gonna be 2n plus 2, 2n plus 1, and then 2n factorial, which will cancel. So we'll have 2n plus 2, 2n plus 1, and then the 2n factorial cancels. This and this are going to leave me with the absolute value of x, which is really common. It's very common to get the absolute value of x. And then this and this are going to leave me with just n plus 1. All right, if n goes to infinity, well, we kind of have an issue, right? So if n goes to infinity, I'm going to write that basically x is a constant. So if n goes to infinity, this is infinity. I'm going to say this is infinity. But to make it a little clearer what's happening, I'm going to say it's infinity times the absolute value of x. Because what would happen if before we do anything, before n goes to infinity, what if x is just 0 to begin with? Well, 0 is going to make all these 0, and so the whole thing is just 0. So this is a situation where if, so let's say this. This is infinity if x is not 0, and it's 0 if x is 0. And only one of those is a number that it converges on. So I'm going to say this thing, this is the weird case. It only converges at 0. It only converges at the center. So the center is 0 because this is x minus 0 to the n. So I'm going to say that the series 2n factorial x to the n over n factorial. Is that right? That is right. Okay. Converges for x equals 0, which is just the center. So then what's the radius of convergence? I don't think you'd ever be asked this, but the radius is 0 because you're at 0 and you can't go anywhere. So converges only at 0, the radius is 0. I'm going to stop that there. I'll come back in the next one and do these two. And we'll see. Hopefully they're like a little more, it's a little more interesting when it's not all reals and it's not like just at the center. So hopefully that happens on these, but who knows. Anyway, see you there.